Hi, welcome back to Math 111. We are going to start in on Chapter 2 and talk about linear functions. This should be mostly review, I hope, from previous classes, so I'm going to go through it kind of quick. Recall from geometry that if you have any 2 points, you can define a straight line through those 2 points, and that straight line will be unique. So if we move either point, the line changes. Okay. We can get a sense of the steepness of the line from the slope, which remember is defined as the difference in y's divided by the difference in x's. So what we're talking about there is, if we think about these 2 points, we're talking about the difference in the y coordinates of these 2 points that define the line divided by the difference in the x coordinates of these 2 points that define the line. So the slope is given by y1, which is the y coordinate of the q point, minus y0, which is the y coordinate of the p point, divided by x1, which is the x coordinate of the q point, minus x0, which is the x coordinate of the p point. And remember that we cannot divide by 0, so that means the x's cannot be equal. That's what this statement right here says. So if we apply that formula to some points, and we're just going to do a few of these. I'm going to leave the rest of them to you to practice. So let's talk about number 1 here. The slope is y1 minus y0 divided by x1 minus x0. Let's call this Q will be 0.1, so that means that y1 is 4, minus y0, which is the y coordinate of the p point, which is 0, divided by x1, which is x of q, which is 2, minus 0, which is 2. 4 minus 0 is 4. 2 minus 0 is 2. 4 over 2 is 2. Okay. Let's look at the graph of the line that goes through these 2 points. We actually have it graphed right here. So this number 1 is, the P point is down here at the bottom, 0.00, and the Q point is up here, 0.24. And we said we had a slope of 2, which means we're expecting to be able to go up 2 and to the right 1. And sure enough, we get to another point on the line. We also have a positive slope, so we expect an upward slant from left to right, and that's what we have. Okay, let's look at another one. Let's look at, I'm going to let you do some of these for yourselves. So I'm going to let you do number 2 and number 3 for yourself. Make sure you can get the answer that shows up on the next page. We're going to do number 4. So the slope of these 2 points is the difference in y's, which means 2 minus 2, divided by the difference in x's, which means 4 minus a negative 3. So that's 0 over 7, or 0. What did I say about slope if we had slope 0? We are going to expect a horizontal line. So let's take a look at the next slide. And number 4, sure enough, this is point P, negative 3, 2. And this is point Q, 4, 2. Their y's are equal, so it's a horizontal line. It's got slope 0. All right. Let's take a look at number 5. Number 5 says that we've got a point, 2 points with a line going through them. The difference in y is going to be negative 1 minus 3, divided by the difference in x's, 2 minus 2. Uh-oh. We get negative 4 over 0. We can't do that. My calculator screams if I try that. 4 divided by 0 is an undefined number. This line has a slope that does not exist, which means it is what? Yes, a vertical line. So if we look at our slide, number 5, sure enough, is vertical. Okay, I want to take a look at number 6 too, just because this guy looks like it might be vertical if you haven't graphed very carefully. So let's take a look at this. Number 6, the slope is the difference in y's divided by the difference in x's, which is -4 over 0.1 or 40. So this guy's got a very big slope. What this means is if we go over 1 on the x-axis, we need to go up 40. That's why this looks almost vertical, but it's not. So we want to be careful and not just rely on the graphs. We want to look at the coordinates of the points. Okay. Just a quick overview of what I have said here. If a slope is positive, then the line is said to be increasing. And what that means is the line slopes upward from left to right. We're going to read our graphs the same way we read our English, which is from left to right. So a line with a positive slope will be increasing. The y's will be increasing as we move from left to right. If the slope is negative, then the line is decreasing, meaning it will fall downwards as we move from left to right. And a slope of 0 is always correspondent to a horizontal line. And an undefined slope always corresponds with a vertical line. Okay, sometimes we say that the slope is equal to the rise over the run. The rise is how far up we go to get from one point to the next on a line. The run is how far over we go. Someone once told me they remembered this by saying that you have to rise up out of your chair before you can run from the room. Rise over run. Okay. Now, sometimes you'll see this delta. This delta is a Greek letter. It is the Greek letter delta. That's what this little triangle is. All it means is change in. When we see delta y, we mean change in y. That's the same thing as y1 minus y0. So sometimes you'll see the slope written as delta y over delta x. That just means the changes in y divided by the changes in x, which is just the rise over the run. Slope is an expression of a rate of change because it tells us how fast y is changing with relation to x. So here's an example. We have got, we wake up in the morning and at 6 a.m. it's 24 degrees. We notice later in the morning that at 10 a.m. it's 32 degrees and we wonder, how fast is my temperature rising? And if it keeps it up, how warm is it going to be by noon? Okay. Well, let's start with how fast is the temperature rising. What we're really asking is how many degrees does the temperature go up every hour? That's the same thing as the slope of the line that we would get if we graphed our temperature points. So if we made a graph of the temperature over time, we would have a point at 6 a.m. and 24 degrees and a point at 10 a.m. and 32 degrees. We can find the slope using our slope formula. y1 minus y0, or the temperature at 10 a.m. minus the temperature at 6 a.m. divided by x1, or 10 o'clock, minus x0, or 6 o'clock. So 32 minus 24 is 8. 10 minus 6 is 4. So my slope is 2. What this means is we're raising every 2 degrees every hour. That's my slope. And I just gave you the interpretation. The temperature increases 2 degrees for every hour that passes. So how can we use that to project the temperature at noon? Well, if we know that the change in temperature divided by the change in hour is 2 degrees for every hour, that's like temperature 2 minus temperature 1 divided by time 2 minus time 1, right? Okay, well, how many hours will have passed between, say, 10 and noon? Well, 2, but we can get that by taking 12 minus 10. We don't know the temperature at noon, that's what we're trying to find, but we know the temperature at 10. And so this is the equation that we can use, to find my temperature. So what that means is that temperature 2 minus 32 is equal to 2 times 12 minus 10. Or if you do just a little bit of arithmetic and algebra, you get that at noon it's going to be 36 degrees. If you have any questions on that, let me know, okay? Okay, now what I did there was actually use this thing that is called the point-slope form of the equation of a line. And this comes from the slope equation, really. But what it tells us is that we can write the equation of a line. So y and x are just variables, okay? We know the slope, or we can find the slope. And x0 and y0 are the coordinates of a point on the line. So if we know the slope and one point on the line, then we can write the equation of the line using this point-slope form. Now, if you are a little freaked out about learning a new form of the equation of the line, don't despair. We can still do all of this work the way that you did it in Math 70 with the slope-intercept form and the y equals mx plus b form. But let's just see how this works. So we're going to have 2 points, okay? And we're going to write an equation of the line, and I'm going to use this form. So I'm going to use y equals my slope times x minus x0 plus y0. Now the slope, let's find the slope. 1 minus 3 divided by 2 minus negative 1, which is 1 minus 3 is negative 2 over 2 minus negative 1 is 3. So it's negative 2/3. So that means y equals negative 2/3 times x minus, now x0 can be either one of these 2 points. Let's just use this one. So minus negative 1 plus the y coordinate of the point I chose, which was 3. So this will be negative 2/3 x. Now minus a negative 1 is plus 1 times negative 2/3 means minus 2/3 plus 3. So we've got y equals negative 2/3 x. Combine the minus 2/3 and the plus 3 and we get plus 7/3. Okay? Now, we can do this same work through a two-step process using the slope-intercept form of the line, which is probably what you learned in Math 70. But here we did it all in one step using the point-slope form. I'm not going to test you on the point-slope form. I just want you to be able to get from the 2 points to the equation. But I may use the point-slope form in class, so try to wrap your mind around this. Here's your good old friend, the slope-intercept form. Slope-intercept form of the line is y equals mx plus b. M is the slope, and b is, remember, the y-intercept. So its x-coordinate is going to be 0, and that's the point where the line crosses the y-axis. We write linear functions as f of x equals mx plus b, because if you remember from when we were graphing functions in the first section, f of x and y are really interchangeable. And we're going to define linear functions to be sloped lines. So we're going to say that the slope is not 0 if we have a linear function. Because we're going to give lines that with slope of 0, horizontal lines, special name of the constant function, because our output is constant. It doesn't matter what our input is. We always get the same thing out. Okay. So to graph a linear function, a constant function, we pretty much do the same thing we did when we graphed functions last chapter, right? We realized that y and f of x were the same. A linear function is always going to be a straight line with a slope and a y-intercept. A constant function is a horizontal line, i.e. slope is 0, and a y-intercept. If we've got a line with a positive slope, that's going to be increasing. A line with a negative slope is decreasing. And horizontal lines are functions. Or excuse me, horizontal lines are constants. Okay. I'm not going to go through most of these because most of them are pretty self-explanatory. To graph f of x equals 3, make a table of values, plot a few points, draw a line through. You'll get a horizontal line. If to graph f of x equals 3x minus 1, you can do it a couple of different ways. You can make a table of values. You can remember that you've got a y-intercept at -1 and a slope of 3. So you can start at the y-intercept and then use your slope to get to another point and draw the line. With this one, you just need to be careful that you realize where your x is and then rewrite it. The one I want to go through here with you is this fourth one. So I'm going to go through number 4. I'm going to leave numbers 1, 2, and 3 for you to practice on. The answers will show up here in a minute. Make sure you know how to graph these. If you don't, ask me the question. Okay? But let's talk about this fourth one. What I have is f of x equals x squared minus 4 over x minus 2. Now we recognize that that's a rational equation and we need to simplify it. And the way we simplify this, we could do the long division, we could use synthetic division, or we can factor. And simplify, and that's what I chose to do. So I recognize this top as a difference of perfect squares, which will factor. And now look at there, my x minus 2's cancel. And this thing reduces to a straight line given by x plus 2. But there's one little hiccup. You see this? I started off with a negative x minus 2 in the denominator. Since we can never divide by 0, that means we have to exclude x equals 2 from our domain. So if we take a look at the graphs here, and there is a typo on this slide. This should be x minus 2 because that was actually what our function said. Okay? So that's x minus 2, not x plus 2. And sure enough, we've got the slope of 1 that we expected. We've got the y-intercept at 2, and we've got a hole right here. What this hole means, that hole means that x cannot equal 2. Okay? All right. If you don't know how to get these graphs, please either put a question on the forum or get a hold of me, and we will talk about what we need to do. Okay, now let's talk about a real-world example. Porta-Boy game systems cost a local retailer $80 per game unit, that's the 80X, plus a flat order fee of $150. That's what the $150 means. So we want to do some work here. Make sure we understand this. We want to look at C of 10. Now, what does C of 10 mean? Well, that would be the cost Sorry, it took my pen away. Give it back. So the cost, if we know C of X equals 80X plus 150, we're told this is the cost function for a gaming system. C of 10 means we ordered 10 units. So we find C of 10 by replacing all of our X's with 10s. And we find that the cost of 10 units is $950. So what this means is it costs $950 to purchase 10 game systems. Now, let's see how many does it, so say we've got $15,000 to invest. How many systems can we produce? Well, so what we're really saying there is my cost is equal to 15,000. 15,000 or 1,500? 15,000. But we know that we can find C of X as 80 times X plus 150. So what we're really asking for is solve for X if my output is 15,000. So let's subtract the 150 from both sides. And we get $14,850 equals 80 times X. Find my calculator here. Hold on. Yeah, there it is. No, that's not it. Oh. Okay. Give me a second here. I'm going to open up my desktop calculator. Okay. There it is. All right. So I needed my desktop calculator, or a calculator at any rate, because now I have to divide 14,850 by 80. So I'm going to do that on my calculator. It's going to divide this by 80. And I get X equals 185.625. Now, can I make 0.625 units? No. And I can't make 186 units because then I will go over 15,000. So I can make only 185 units for an investment of $15,000. Okay, doesn't seem like very many gaming units for that much money, does it? But that's what we got. All right. So the answer to this one was 185. Now, there's an extra restriction here that says that X has to be greater than or equal to 0. Why? What's X represent? X represents the number of gaming systems, right? We're not going to make a negative number of gaming systems. Okay. C of 0 is what? If I plug in 0, I get 150. This is the flat order fee. It's a fee that is assessed just for me to produce by even one VPUT. Even if I weren't going to buy any units, in theory, this is my minimum cost, right? Okay, and what's the slope? Slope is 80, right? What that means is it costs an extra my cost increases by $80 for every additional gaming unit I purchase. Okay? All right. If any of that doesn't make sense to you, be sure and ask whatever is bothering you. I will clarify. Let's finish up with a little bit of expansion on this example. So we had the cost function. So it costs this much. My cost function, the cost to produce the gaming systems, is given by $80 per gaming system plus a flat fee of $150. Now, this retailer has noticed that the number of systems that he can sell is related to the price. So when he charged $220, he only sold 20 games. But when they went on sale for $190, he sold 40 games. So let's see if we can figure out a linear function that represents this data. And we're going to use X as our weekly sales and P for our price. So what we're looking for, we're trying to find P of X equals something times X plus B. Or let's use the other form. Let's use P is equal to M times X minus X1 plus P1. And we've got 2 points. We've got a point 20 to 20. So I sold 20 units when the price was $220. And I sold 40 units when the price was $195. Right? Let's check that second point. Yes. So what have I done? Oops, I've not followed instructions. Okay, we'll fix that. This says use X. Oh, yes, I have. I've followed instructions. This says use X as the independent variable and P as the dependent variable. So we're calculating price as a function of units sold, and that's what I've written down. Okay, so I've got my X's are my X's are my units sold. My P's are my price, or those are my Y. Okay, let's find the slope. 220 minus 195 divided by 20 minus 40. And that's going to give me, I got my calculator again. So I can do this all at once if I'm careful with my parentheses. Put my whole numerator in parentheses and my whole denominator in parentheses. And my slope is negative 1.25. Okay, negative slope. Does that make sense? I sell more when the price is lower. Yes, that makes sense. So negative 1.25. Okay, so now we're going to plug into this formula up here. Price is equal to my slope, which is negative 1.25, times X minus, and I can pick any point for X1. I'm going to use this one. So X minus 20 plus 220. And that's going to give me, and I'm going to distribute, so negative 1.25X plus, let's take my calculator, multiply negative 1.25 times 20, and I get 25. Y plus negative 1.25 times negative 20 is plus 25. plus 220. So my price function is negative 1.25 plus 245. There we go. Whoops, need an X. There we go. So P of X, my price as a function of X, is equal to negative 1.25 times X plus 245. What's this mean? Well, what it means is that my price, my number sold will drop. No, it means that for each additional unit I want to sell, I need to drop my price by $1.25. And that the absolute highest price I can possibly charge and sell 0 units is $245. Okay? All right, so that was the answer to the first one. The first one, price as a function of units sold. P of X equals negative 1.25x plus 245. What is a domain that makes sense? Well, do I want to sell a negative number of units? No. Right? And we already talked about the slope. It means that for every additional unit that I want to sell, I need to drop the price by $1.25. So let's say I want to sell 150 units. What should my price be? Well, what that means is I'm trying to find P of 150. So I replace my X's with 150. Whoops, sorry, that should be 245. So now let's take out my calculator. $150 times negative 1.25 plus 245, and I should charge $57.50. That's what this says. That means I need to reduce those prices all the way down to $57.50. Now let's think about that for a minute. Am I actually going to make any money if I do that? To prove that to yourself, go check out what the cost function is for 150 units. Yeah, it costs at least $80 to make each unit. That doesn't make much sense, does it? We're not going to be able to sell 150 units. Okay, so this would be $57.50. And what's this say? This says that you want to solve the equation 150 equals negative 1.25x plus 245. Okay, we'll do more with cost and sales functions later on in the term when we get to quadratic equations. So I'm not going to do this last one. Be sure you know how to do it. If you don't, ask me about it in class. Okay? All right. So the slope of a function, or the slope between 2 points, really represents an average rate of change. Graphically, so the reason we care about this, so let's think about what we're doing. We've got 2 points, right? And we draw a line between them. And that is the slope. Now, what if those 2 points are on a curve? Well, that's not the slope of this curve, right? But it is the slope of the line that goes through those 2 points. So we call this the average rate of change. It's really the change in outputs divided by the change in inputs. That's just another word for slope. Driving is a perfect example of this. So let's suppose that you drive 100 miles and it takes you 2 hours. You can take 100 miles and divide it by 2 and get 50 miles per hour. That's your average speed. But let's say you went through a town in there and you had to drop to 25 miles an hour. Well, during that period of time when you were in that town, you weren't going 50 miles an hour. You were going 25. Your speedometer reading at any second, any moment in time gives you your instantaneous rate of change, or your instantaneous miles per hour. Okay. We're going to talk we aren't going to talk much about instantaneous. I just want you to realize that instantaneous is kind of like, remember when I drew those 2 points on the graph? Well, if I move those 2 points closer and closer and closer together, then my average rate of change becomes closer to my instantaneous rate of change. This is something you talk a lot about in calculus. I just wanted to mention it here so that you have at least seen it. Okay, so back to those Portaboy gaming units. I told you we were going to talk more about this later. We'll talk about it now. Revenue, so the amount of money that we will make, is equal to the number of units sold multiplied by the price. And so let's think about that for a minute. We found our price function a minute ago, right? Our price function was given by P of x equals negative 1.25x plus 245. So my price, as a function of the number of units sold, is negative 1.25 times x plus 245. Just a minute ago I said that revenue is equal to x times p. But p is a function of x. And what's more, p is defined as negative 1.25 times x plus 245. It's a 4, not a 9. So that means that my revenue is not a linear function. It's 1.25 times x squared plus 245x. This is my revenue function. So this is the amount of money that will end up in my cash drawer at the end of the week. Okay. That's number one. There's your revenue function. R of x equals negative 1.25 times x squared plus 245. Whoops, sorry. Plus 245x. I'm not going to be able to get that on there. Okay, so we got number one. What's number two? We want to talk about the average rate of change over the interval 0 to 50. What that means is we are looking at x equals 0 to x equals 50, or 0 is less than or equal to x is less than or equal to 50. Let's use Desmos here, because Desmos is slick. Okay, so my revenue function, R of x, is equal to negative 1.25 times x squared plus 245 times x. And I clearly need to zoom out. Way out. I'm going to have to change the scaling on my y. Give me a sec. And I'm going to just see, it doesn't make any sense to look at zeros, so we're going to go to 0 to, oh, let's go 0 to 300 on the X, and 0 to 13,000 on the Y. All right, that'll do. Okay. Will that do? Let's see. Yes, that'll do. All right, so now this is my revenue function. What I want to know is the average rate of change between the point where X is 0. So that's going to be 0. So if I don't sell anything, what is my revenue? 0, right? Yeah. And 50. So if I sell 50 units, what is my revenue? Well, that's going to be negative 1.25 times 50 squared plus 245 times 50. Okay, so those are my revenue points. This one and that one. Now, how do I find the average rate of change between those? It's just the slope. Let's use Desmos to find that slope. So my Y, which is 91.25, that's the Y of 50, minus my other Y, which is 0, divided by my X, which is 50, minus 0. And Desmos tells me right here that my average rate of change between those 2 points is 182.5. So let's just take a look at that for a minute. I'm going to put another line on here. And that line is going to be the line that goes through those 2 points. And I'm going to limit it to just going between those 2 points. All right. Make my keyboard go away because it's obscuring my graph. Now, we can see that my revenue function doesn't quite lie along that line, but it's pretty close. So I can kind of use this average rate of change to estimate the change in my revenue between selling 0 and 50 units. So my average rate of change here is 182.5. What this really means is that for every additional unit, whoops, sorry, it's here. So that means that for every additional unit that I sell between 0 units and 50 units, my revenue goes up by $182.50. Well, that's not bad. Okay, now let's talk about what happens if I go from 50 to 100. Can I still do that? Okay, so let's put another point on here. Let's put on the point 100. And then the Y that goes with that's going to be negative 1.25 times 100 squared plus 245 times 100. Okay. Can you see it? It's right up here. Let me zoom out just a little bit. There we go. Okay. What's my slope between the black line, black dot, and the green dot? Well, let's figure that out. That'd be the difference in Y, so we'll say 12,000, because that's the Y at the green, minus 91.25, because that's the Y at the black dot, divided by the difference in X's, which is going to be 100 minus 50. And look at that slope's that slope's only 57.5. So that's a lot lower. Let's put that line on there. I'm going to use the other form. So this is going to be 57.5 times x minus one of my x's plus one of the same y. There we go. And I'm going to limit that to 50 is less than x is less than 100. Because what this does is it really illustrates for us. Look at the difference in slopes between those two lines. Okay? We're at a different part in the curve, so my slopes are different between these two lines. The average rate of change between 50 and 100 is much less than the average rate of change between 50 and 0. So once I get to more than 50 units, I make a little less on each additional unit. Here, my average rate of change is only 57.5. Whoops. So my biggest increase in revenue comes between 0 and 50 units. Once I start selling more than 50 units, my increase in revenue per unit drops to 57.5 additional dollars per unit. Okay? You can do the same thing, and go ahead and use Desmos to do this, but play around and see what you get for number 4. It's kind of interesting. Let me know what you find. Put that on a forum. Put it in the Chapter 2 forum. Okay. So, I will put a question out on the forum for everybody to answer. What is the average rate of change in weekly revenue as weekly sales increase from 100 to 150 porta boys? All right, that's it for today. Everybody have a great day, and I will talk with you soon. Let me stop my recording.